Whenever we talk about mathematics and mathematicians, we just talk about Newton, Blaise Pascal, Leonard Euler, Jacobi. But there was one more we miss. His name is Srinivasa Ramanujan, the man who created waves in the field of mathematics. An Indian-born mathematician, Srinivasa Ramanujan gave tremendous results in his equations, which are still used in solving greatest mysteries of this world, related to Einstein's equations and also in solving black holes and other things. Today, we remember him on his 135th birth anniversary. During a class, when the teacher said 3 divided by 3 equal to 1 and 100 divided by 100 is also equal to 1, he said something divided by itself is always equal to 1. Caught up with curiosity, Ramanujan said, what would be 0 divided by 0? He said 0 divided by 0 should also be equal to 1. The teacher was perplexed, but little Ramanujan was curious since his childhood, and the curiosity remained till his death. Srinivasa Ramanujan, the man who reshaped 20th century mathematics with his various contributions in several mathematical domains, including mathematical analysis, infinite series, continued fraction, number theory, and game theory, is recognized as one of the history's greatest mathematicians. Living this world at the youthful age of 32, Ramanujan made significant contributions to mathematics that only a few others could match in their lifetime. Surprisingly, he never received any formal mathematics training. Most of his mathematical discoveries were based on only intuition and were ultimately proven correct. With its humble and sometimes difficult start, his life story is just as fascinating as his incredible work. Every year, Ramanujan's birth anniversary on December 22nd is observed as National Mathematics Day. Born in Erode, Tamil Nadu, India, Ramanujan demonstrated an exceptional intuitive grasp of mathematics at a young age. Despite being a mathematical prodigy, Ramanujan's career did not begin well. He received a college scholarship in 1904, but he quickly lost it by failing in non-mathematical subjects. Another attempt at college in Madras, now Chennai, ended in failure when he failed in first arts exam. It was around this time that he began his famous notebooks. He drifted through poverty until 1910, when he was interviewed by R. Ramachandra Rao, Secretary of the Indian Mathematical Society. Rao was initially susceptible of Ramanujan, but he eventually recognized his abilities and supported him financially. Srinivasa Ramanujan began developing his theories in mathematics and published his papers in 1911. He was mentored at the Cambridge by G. H. Hardy, a well-known British mathematician who encouraged him to publish his findings in a number of papers. In 1918, Ramanujan became the second Indian to be included as a Fellow of the Royal Society. Ramanujan's major contributions to mathematics. Let's talk about Ramanujan's major mathematical contributions. Ramanujan's contributions extend to mathematical fields such as complex analysis, number theory, infinite series, and continued fraction. Infinite series for pi. In 1914, Ramanujan found a formula for infinite series for pi, which forms the basis of many algorithms used today. Finding an accurate approximation of pi has been one of the most important challenges in the history of mathematics. Game theory. Ramanujan discovered a long list of new ideas for solving many challenging mathematical problems that have given great impetus to the development of game theory. His contribution to game theory is purely based on intuition and natural talent and is unmatched to this day. Mach theta function. He elaborated on the Mach theta function, a concept in the field of modulus forms of mathematics. Ramanujan number. 1729 is known as Ramanujan number, which is the sum of the cubes of two numbers, 10 and 9, or 12 and 1. Circle method. Ramanujan, along with G.H. Hardy, invented the circle method, which gave the first approximation of the partition of numbers beyond 200. This method contributed significantly to solving the notorious complex problems of 20th century, such as varying conjecture and other additional questions. Theta function. Theta function is a special function of several complex variables. German mathematician Carl Gustav Jacobi invented several closely related theta functions known as Jacobi theta functions. Theta function was studied by intensively Ramanujan, who came up with the Ramanujan theta function that generalizes the form of Jacobi theta function and also captures general properties. Ramanujan theta function is used to determine the critical dimensions in bosonic string theory, superstring theory, and M theory. Other notable contributions by Ramanujan include hypergeometric series, the Ramanujan series. Other notable contributions by Ramanujan include hypergeometric series, the Riemann series, the elliptical integrals, the theory of divergent series, and the functional equations of the zeta function. Ramanujan's achievements were all about elegance, depth, and surprise, beautifully intertwined. Unfortunately, Ramanujan contracted a fatal illness in England in 1918. He convalesced there for more than a year and returned to India in 1919. His condition then worsened and he died on 26 April 1920. One might expect that a dying man would stop working and await his fate. However, Ramanujan spent his last year producing some of his most profound mathematics. It has been more than a century, however, his mathematical discoveries are still alive and flourishing. And when the people and mathematicians asked him where did he get those equations and where did he learn from those equations and theorems, he simply used to say, Goddess Namagiri comes in my dreams and she tells me these equations. Ramanujan is important not just as a mathematician but because of what he tells us that the human mind can do. Someone with his ability is so rare and so precious that we can't afford to lose them. A genius can arise anywhere in the world. It is our good fortune that he was one of us. It is unfortunate that too little of Ramanujan's life and work, esoteric though the latter seems to be known to most of us.